Hi folks, Dr. P here. This is Math 20-2, Quadratic Functions, Topic 3, Example 1 on page 40. So in this question, they are asking us to identify the characteristics of quadratic functions in vertex form. So just a very quick review of vertex form. A quadratic function in vertex form means that it will be looking like this: y equals a times x minus h squared plus k. Okay, it means so when it's in vertex form, it means it's a quadratic function. It'll have a parabolic shape, so it sort of opens up or down. If we have vertex form, we can always identify the vertex just by looking at the equation. The vertex is going to be h, the x coordinate is going to be h, and the y coordinate is going to be k. So we can just pull out the k, and that's going to be our y coordinate of the vertex, and then we pull out the h, and that's going to become our x coordinate of the vertex. What you need to pay attention to here, however, is that in front of this h in the vertex form, there's a minus sign, which means that this h is actually negative. When we're taking out this parameter h to use it as the x coordinate of the vertex, we have to flip the sign of the h. So if it's negative, the x coordinate becomes positive. If it happens to be positive, the x coordinate becomes negative. So it's just something to keep in mind. All of this is summarized in your workbook on the previous page. So it's going to be page 39. I'm just going to go up and show you. All of this is summarized right here. So make sure you look through that before you do this assignment. Page 39. Okay. The other thing we can do if we have our quadratic function in vertex form, we can look at the sign of the a. If a is positive, so if a is larger than 0, it means that the quadratic function, the parabola, opens up. And anytime we have a quadratic function that opens up, it means we have a minimum. That's if a is positive. If a is negative, which means it's less than 0, we will have a quadratic function, a parabola, that opens down. And anytime we have a quadratic function that opens down, we will end up with a maximum. All right, so let's move on to this question here. They're giving us a quadratic equation in vertex form right here. And what we're going to do here is we're going to identify these characteristics without using a calculator. All right. So direction of opening, well, that's going to depend on the a. The a here is 2. So this 2 here, that's our a. A is positive. And we just said up here that if a is positive, the parabola opens up. Okay. In the next one here, they're asking us for the vertex. So if we take a look at the vertex form, this here, that's going to be our k. K equals 5. And this here is our h. H equals negative 4. So that means that the equation, the coordinates of the vertex, the x coordinate is going to be positive 4. We have to flip that sign. And the y coordinate of the vertex is going to be 5. Vertex is going to be positive 4 and positive 5, x and y coordinates. Do we have a minimum or a maximum? Well, anytime we have a parabola that opens up, it's going to be looking something like this, right? Means we have a minimum. y min. Okay, the coordinate of that minimum, the y coordinate of that minimum, will be the same as the y coordinate of the vertex. It's going to be 5. At this point, we can put that in here. So we know that the vertex is going to be an x coordinate 4, y coordinate 5, which is right there. And we're going to be opening up axis of symmetry. Well, the axis of symmetry goes through the vertex. So the x coordinate of the axis of symmetry is going to be 4. Domain, well, for quadratic functions, the domain, unless there are restrictions imposed by a context, if they're not, like here, the domain will always be x belongs to the set of real numbers. X goes from negative infinity to positive infinity. The range, well, so let's think about how this parabola will actually look. So this is the vertex, and then it's going to open up. So it's going to go something like this. Right? So it means that for the range, the smallest possible y value will be the y coordinate right there. So the range will be y greater or equal to 5. Never going to be smaller. And then finally, the number of x-intercepts. So here we have a situation where this quadratic function never crosses the x-axis. X-axis is way down here, and it will never cross it, which means that there are no x-intercepts. So a quadratic function can have no x-intercept. It could have one x-intercept, or you can have two x-intercepts. So make sure that you review that. Again, that's going to be on page 39, the previous page. Here it's talking about the situation with two x-intercepts. Oops. Two x-intercepts, no x-intercepts, which is what we just encountered, and one x-intercept. When we're talking about a one x-intercept, it means that the quadratic function comes up to the x-axis, it just touches it and then turns around. So if it opens down, it'll look like this. If it opens up, it'll look like this. It'll never actually look like it's crossing. It just touches the x-axis and then turns around and goes off either down or up. That's a wrap. This is example 1a. There's also a B question and a C question. You have these two questions keyed in your in the posted workbook on Google Classroom. Make sure you check that out. And if you have any questions, make sure you join a Google Meet. We have one every day. Or submit your question through the question form on Google Classroom. Until next time, stay safe, stay healthy, and may the math be with you. See ya.